Okay, good morning everyone. So let's actually start. Okay, so let me check your uniform. Okay, Shane, Justin, switch on the video. Okay, so we will actually straight away continue with our reactions of amides. Okay, so let's actually continue. Yeah. So for the amides. Okay, so we are going to actually look into the amides. Yeah. So if you look at carbon, okay, if you have carbon and then we have double bond O and then we have NH2, okay, and then you have R. If you compare this, okay, with carbon having NH2, okay, let's say anything CH3, or let's say if you have nitrogen, then 1H CH3 here, CH3 here. Or if you have nitrogen, CH3, CH3, and CH3 here.
What have you done? You didn't find the day after zoo English lesson.
Okay, guys, give me 2 minutes for a while. Okay, guys. Okay, I'll continue. So here, okay, if you look at this, okay, which is going to be, okay, we have this structure, which is going to be, okay, if you look at the structure, okay, of this structure over here, this is the structure of amide, okay, and these three, okay, that I have drawn over here, they are all structures of amide. Okay, so if you have this NH2, okay, attached to it, or NH, okay, then 2R groups or 3R groups attached to N, all these are going to be considered to be amines. And we have learned about amines, okay, in our previous lesson. So if you look at now, what we are going to look is what are the reactions of amide. Okay, so do remember amide. Okay, it can be also substituted amide. Okay, like for example, if I have RC double bond O, I have nitrogen, one of the H is replaced by CH3. Now this is also known as amide. Okay, this is also known as amide. So it's going to be as long you have, okay, carbon bonded to O and then there is nitrogen over there. This is going to be what we call as amide. Okay, so this one is going to be named as substituted amide. Okay, so let's actually move on further. Okay, so what are the reactions of amides? Okay, the structural formula, okay, the one that normal, yeah, the normal, let's say unsubstituted amide is going to be RC double bond O NH2. This is going to be the amide, okay, the structural formula. Now we have learned, okay, that NH3, and we have learned that amine RNH2, okay, and we have learned about phenylamine, okay, and H2. All of them we have learned as basic. Okay, why they are basic? Because they have lone pair of electrons, okay, which are ready, okay, to be bonded or to be forming the dative bond with a proton, with the H plus. Okay, so but they have different strengths. Okay, like for example, if you look at the, if I want to compare, okay, if I want to compare, if let's say methyl amine over here, okay, let's say CH3NH NH2, okay, this is going to be much more, okay, better base. Okay, why? Because if I look at R is going to be electron donating group. Okay, so electrons and electrons, they will repel. Okay, so when the electrons repel, this particular electron, they are going to be ready to be bonded. So they are going to be, let's say you have H plus, they are going to be readily available to be bonded. So this amine is going to be much more better basic, okay, better base. But if you compare with this phenylamine, okay, phenylamine, the lone pair of this at that nitrogen, they will go and enter the benzene, and they will become delocalized, okay, and they are going to be stabilized, okay, with the pi system over here. Okay, so the ring system, okay, is going to be it's going to be, the electrons are going to enter the ring of the benzene. Okay, so because of that, okay, these electrons, okay, the lone pair of electrons are going to be less available for bonding. Okay, it's going to be less available for bonding. Okay, okay, so that is going to be, okay, the basic, yeah, amines are basic. So we want to actually know about how about amides, are they going to be basic? Okay, that is what we need to answer. Okay, the reason the amides, okay, if you compare, okay, with amines, okay, they are neutral. Okay, this is very, very important. Okay, they are neutral. And to answer the question why they are neutral, why they have C double bond O and H2, why suddenly now, okay, they are neutral, they do have lone pair of electrons, what happened? Okay, so the thing that is going to happen is the presence of the oxygen over here, which is, I think you know that oxygen is going to be highly electronegative. They are able to withdraw the electron, so they are going to make the lone pair of the amide N atom not available for donating. So it means it will go towards this oxygen. Okay, so they are not going to be available for bonding. Okay, so they are going to be attracted towards the oxygen. Okay, so they are going to be, if let's say you have H plus coming in, you are not going to have this reaction. You are not going to get an H3 plus. This is not going to happen. Okay, this is not going to happen. The reason why? Because oxygen is highly electronegative, so they make the lone pair of the amide nitrogen atom not available to be donated. Yeah, so any question up to here, Charlton?
No.
Okay, Guys, my son needs help, okay, for the marker pen. Give me 2 minutes here. I'll give him marker pen first.
What worksheet is missing now? Okay, sorry, dong.
Okay, now, okay, so let's actually look at how, okay, this part, okay, you know that, okay, amides, they are not going to be basic, okay, so it's neutral. So let's actually look at how do we make amide. But before that, I'm very sure that you know about to make amide, okay, we previously we have learned that in order to make amine, okay, you can actually make amine from amide. Okay, this is preparation of amine. This is going to be done through reduction process. Okay, reduction. So you can use LiAlH4 in dry ether. Okay, so you can change this amide to become amine. Okay, this one we have learned. Okay, but now, okay, how do we prepare amide? Okay, so in order to prepare amide, okay, what we do, okay, this one is related to what we have learned earlier. Okay, acyl chlorides are more reactive than carboxylic acid. So I think in generally, when you want to make something or synthesis anything in your in chemistry, we want something that is more reactive. So let's say, for example, if there is a choice, if there is a choice, okay, that we need to actually choose, like for example, I want. Okay, guys. Now, the acyl chlorides, okay, is going to be more reactive than. Now, the acyl chlorides, okay, they are more reactive than carboxylic acids. And why? Okay, this one I think to answer that, okay, this one, whenever there is a choice, okay, between whether you want to use carboxylic acid or acyl chloride, okay, we always choose to use acyl chloride. Okay, like for example, if I have this carboxylic acid, this is carboxylic acid. Okay, if you have R, and then if I have R double bond O and then Cl, this is acyl chloride. Okay, why acyl chloride is more reactive? So maybe Nicole, Gabriela, Nicole, can you actually answer this? Why acyl chloride is more reactive?
Is it because of the electronegativity availability of the electrons?
Yeah, because I think it is definitely related to that, because we know that The oxygen will also withdraw the electron, okay. But again, when it comes to Cl will withdraw the electron this side, okay. And this is going to make the bond between the C and the Cl to be more available for breaking, okay. So this is the reason why, okay, why it will, this ability, the Cl to withdraw the electron, okay, will actually make it make the bond between carbon and Cl to be readily broken, or to be exact, yeah, what happens over here is going to be more towards, I think if you look at the reaction, I think the better if we try to recall about the reaction, yeah, the reaction that is going to happen whenever that you have this kind of reaction is going to be, of course we know that oxygen will withdraw the electron, oxygen will withdraw the electron, they will withdraw the electron over here, okay. This is going to be, electron will be withdrawn, but do remember they are going to create a positive charge at that carbon, and they are going to create a positive charge at this carbon. So if you have positive charge, this one is called carbocation, okay. Carbocation, or in another words, okay, in other words, if you look at this positive charge, they like to have bonding with negative. So it means, is this electrophile or nucleophile? Jody, do you think the positive charge, is it going to be electrophile or nucleophile?
Nucleophile.
Nucleophile. So they do nucleophile, are you sure? Electrophile, right? They are going to be attracted towards electron, okay? They are positive is going to be attracted towards electron. Like for example, if I have anything coming over, okay, if anything coming over, it means they must be they must be nucleophile. Okay, so the nucleophile is attracted to this compound. Okay, so that is going to be the nucleophilic attack will happen. Okay, so the nucleophilic attack will happen because the chances of it is going to be increased by this Cl, because it's going to create more positive over there. So it means the chances of nucleophilic attack to happen will be greater when it comes to acyl chloride. Okay, this one please read. Okay, we have done this before. Okay, but that is to answer why. Okay, but amide, okay, so acyl chlorides, okay, when I say the second part used in synthesizing amide is, yeah, Jenny's having problem in Zoom. Okay, so if you look at these acyl chlorides are going to be used in the synthesizing of amide. So instead of using carboxylic acid, okay, we use acyl chlorides. So like for example, if I want to have this, how the reaction is going to happen, ethane amide, okay, this is ethane amide. So this ethane amide is going to be made, okay, by reacting ethanol chloride. So this is ethanol chloride, and you react with ammonia. Okay, when you do that, okay, the hydrogen from here, one of the hydrogen over here, they are going to combine with the Cl over here. So they are going to give you the white fumes of ACl. And they are going to give you the remaining NH2 will go and join. So you are going to get this amide. Okay. So if you look at other reactions, there is something that just I informed to you. There are something what we call as substituted amide. Okay, so similar reaction. If you have NH3, okay, if you have amine, it can still react with amine. So how? Similar reaction. One of the H over here, okay, will react with this Cl. So you have HCl. The remaining one, okay, this one will stay. So you have NC2H5. So you will have this amide. This is actually what we call a substituted amide. How to identify whether it's amide? I already mentioned to you earlier, C double bond O and then N. If you have that, this is a confirmation that this is going to be amide. Both of the reaction happens at room temperature Releasing what? You can see both of them are releasing HCl. So the HCl I have mentioned just now, they are going to be in chemistry in lab. Okay, what do we see? We see white fumes. Okay, we see white fumes. HCl is always being referred as white fumes being released. Okay, now if let's say you have excess amine, okay, if you have excess amine, so let's say this is going to be a lot, it will react with HCl to make it salt. Okay, like for example, if you have too many amine, okay, they are going to actually, let's say for example, you have a lot of this. Okay, if you have a lot of this, C2H5 and H2, they are going to react with the HCl, okay, to make a salt. Okay, so if you have HCl, they are going to give you C2H5 NH3 plus Cl minus. Okay, this is going to be some sort of a ammonium chloride salt. Okay, this one, okay, it's quite simple also. So the first one, okay, the reaction to make amide, we react acyl chloride with ammonia, concentrated ammonia, or you can react with amine. Okay, we can react with amine. So both reactions happen at room temperature. So do remember, if you want to react with ammonia, it must be concentrated room temperature. Room temperature. Both of them are room temperature. Why room temperature? This is a no-brainer, you know, because we know that acyl chloride is reactive. So if it is reactive, you do not need to provide any heat. Okay, so it's going to be vigorous reaction. Now, N is used to name amide, okay, to denote which alkyl or aryl groups are bonded to the nitrogen atom. Okay, this is how to name. Yeah, so like for example, if I have butane amide, okay, so if you have N-ethyl, okay, so the nitrogen, okay, the nitrogen is going to be bonded to the ethyl. Okay, so the N is used in the naming of amide to denote which alkyl group are bonded to the nitrogen atom. So like for example, if I have nitrogen, when I want to draw N-ethyl butanamide, N-ethyl, so you just draw N, then draw ethyl. Ethyl is C2H5. Okay, and then butanamide, okay, amide. So again, this is going to be nitrogen, so this is automatically H. There will be carbon, there will be double bond O, okay, and then it's butanamide, so there should be four carbons here. So one carbon is already there, so another one, okay. So this is going to be something like that. So if I want to write down the structural formula, okay, this is going to be C3H7 CONH C2H5, which is going to be this one. Okay, so if C2H5 has replaced an H atom, so this one is going to be, if you have NH2, okay, this one C2H5 has been replaced. Okay, so this is butanamide and ethyl butanamide. So if H atom is replaced by another alkyl or aryl groups, okay, two N's are used. Okay, like for example, if you have C double bond O and then you have C2H5, C2H5, and this is going to be bonded with C3H7. How do I name this? Okay, this is going to be, because this nitrogen is bonded to ethyl, then there is another ethyl, so it's going to be NN. Okay, so diethyl. Okay, we know this is amide. So how many carbon amide? So one and then another three, so four. So butanamide. Is it okay, Jody, so far?
Yes.
So is it possible to have N and N? It's not possible. Okay, maximum 2N only. Okay, maximum 2N only. Yeah. So this is going to be the naming, okay, the naming. So what are going to be the reactions of substituted amides, okay? So we have learned how to make amide. Now these are going to be the reaction of the amide, okay? So the bond, okay, if you look at this bond, this is going to be NH. So let it be H or any R group, okay? Let's say I put R1. So this one, just leave it like this. Okay, they mentioned that, okay, the CO and H group can be broken. So it means this group can be broken. Okay, how you can break this bond? Okay, how do you break this CO and H? Okay, by using hydrolysis reaction. So the hydrolysis can be done by either acid or alkali. Okay, you can use either acid or alkali. We call it acid hydrolysis or alkali hydrolysis. Now, the products of hydrolysis, okay, are going to be carboxylic acids and primary amine. Now, do remember to form this, okay, earlier what we use, let's say, I give you one example of amine, CH3, C double bond O, and H, let's say CH3. This is one example of amide. And in order to form this, okay, in order to form this, how do I form this? I will form this by using CH3, C double bond O, Cl plus CH3, NH2. Okay, I will react amine and ethanol chloride, or I react acyl chloride and amine to get this. Okay, so if I want to break, normally I expect that I'm going to get this and this. Do remember, we do not use carboxylic acid and amine to get amides. Okay, this is how you produce. But when you do hydrolysis, we cannot get this back. Why? Because the Cl and H already went away. Okay, it is released as fumes. Okay, so what do we get if I want to do hydrolysis? Okay, when I break this bond, I am not going to get back this again. When I do hydrolysis, I am going to get CH3, C double bond O, OH, a carboxylic acid, and you are going to get NCH3, H, and then another H over there, okay, which is going to be a primary amine. Okay, so what we do have over here is we are getting the help from OH and H. We are getting the help from water. That's why it's called hydrolysis. Okay, we are going to use water to break. So this water itself, they are going to actually break, and then this OH will come over here, and then the H will come over here. That's why it's called hydrolysis. So the product of the hydrolysis are going to be both carboxylic acid and primary amine. The amine form, okay, sometimes, okay, because we are using, if let's say if we are using hydrolysis by using acid, okay, we know that, okay, we are going to get carboxylic acid and primary amine. Okay, but okay, we know amine, they are base. So base will react with acid. So if you are going to use acid hydrolysis, what happens? The base, the amine that you are going to form, they are going to further react, okay, with the H plus to give you the ammonium ion. Okay, you are going to get the ammonium salt. Okay, the amine form, it means the acid, they do not react with acid, so they will stay. Carboxylic acid will stay. But the amine, they are going to actually change into ammonium salt. Okay, if let's say you are using alkali, okay, base hydrolysis, okay, for example, normally we use sodium hydroxide. The products are still going to be carboxylic acid and primary amine, okay, but we know that, okay, I'll write down COOH first, okay, we know that this and this will be formed. Amine is base, So they cannot react with the OH. So the amine will stay as it is. But the carboxylic acid, okay, we know that they will react if you are using sodium hydroxide. Sodium hydroxide can also react with carboxylic acid. So what happens is the R1COOH, they will react with sodium hydroxide. They will give you R1COO minus and A. So this is going to be the salt of carboxylic acid will be formed. Can you understand this, Victoria? So in a simple, I think in this case, yeah, I have summarized this. Okay, if you are using reflux, okay, this is hydrolysis. You need to reflux. If with acid, we know hydrolysis of amide. Okay, amide will definitely give you carboxylic acid. Okay, will definitely give you carboxylic acid and amine. Okay, it's supposed to give you amine. But what happens, it depends, the product depends on the type of hydrolysis. Are you going to use acid or are you going to use base, sodium hydroxide? If you are using acid, what happens? This will stay. This one, okay, will change into RNH3 plus. Okay, if you are using acid. But if you are using base, okay, the carboxylic acid will react with the sodium hydroxide, for example. They are going to get RCOO and then Na plus, okay, this RNH2 will stay, okay, because the base do not react with base. So this is important. Why does the acid needs to be in excess? How do we tell it needs to be excess or no? Actually, it's not if it is excess, okay, because we are not sure. Like for example, I think this one is actually simple chemistry, Gabriela Nicole. Like for example, if you have this amount of amide, okay, and if you have same amount of acid, okay, if it is complete reaction, nothing excess, it's okay. Or sometimes if it is amide is too many and then the acid is used up, then you are going to get the carboxylic acid and the amine. But sometimes what happens is your acid is more compared to the amide. So in that sense, what will happen? So that is actually, this will happen if it is in excess. Okay, so it means after the reaction is happening, because of the excess of either acid or either the alkali, the reaction will proceed, okay, to give you further reactions. Most of the time, if it is impossible that we measure exactly this amount of acid is going to be reacting with this amount. Okay, so we don't do that. So normally it's always in excess. So when you do that in excess, you will get in this manner. Does it answer your question, Gabriela Nicole?
Yes, yes.
Yeah. Now, so let's actually look at the equations. Okay, it's already 12:10. Okay, so write an equation to show the formation of the following compounds using acyl chlorides. Yeah. So if you are using this, okay, propanamide. Okay, so if you want propanamide, okay, you use this 3-carbon acyl chloride. Then you react with the NH3. Okay, you can actually get propanamide. Okay, or if you want to have N-ethyl propanamide, okay, this is going to be N-ethyl. Yeah, so ethyl is bonded over there. So if you want a substituted, how do we know whether it's substituted or not? The moment you have the naming N, what, N-ethyl, N-methyl, then it's substituted. So if you do not want substituted, then you straight away react with ammonia. Okay, but if you want substituted, then you react with the amine. Okay, so this is how we are going to find out. Yeah, if you have N diethyl propanamide, for example, how do I write the equation? Okay, so N there are 2 N. Okay, so it means ethyl at 2 parts. So it means I want something that has the nitrogen has C2H5, C2H5, and then this one will be my substituted, like for example, any R group over here. Okay, so this one is going to react plus. Okay, so this one, okay, 2CH2. So here I think you need to have at least one R, one H. If you have H here, okay, and then I need to react with acyl chloride. So it's propanamide. So 3 carbon. So 3 carbon. So 3 carbon, double bond O, Cl. And then you can actually have a reaction. So this one will come out as HCl. So you will have something like this. And then N, C2H5, C2H5. This is NN diethyl propanamide. So this one, please actually revise. Okay, write an equation for hydrolysis. Now do remember when they say dilute hydrochloric acid, okay, when they say sodium hydroxide, this is under the assumption, okay, under the assumption not in excess, but you still normally you still need to proceed, because normally, like for example, you see here they didn't say excess here. So they wrote carboxylic acid, okay, they wrote carboxylic acid, and they are going to give you the, in this particular case, it's going to be ammonia, okay. And then they say that if you have more, okay, excess hydrochloric acid, then the NH3 will react with the excess HCl to give you NH4Cl. So similar to that, if you have this example, if you reflux, okay, you are going to get, supposed to give you carboxylic acid and amine, okay, but the carboxylic acid is going to be changed in this O minus Na plus because it is in excess. What is in excess? Sodium hydroxide is in excess. Okay, but no need to mention also, they don't mention. Okay, so it is under the assumption that the reaction will proceed. Okay, even I think here they don't even say it's going to be in excess, it will react. Okay, it will react. Until here, any question? Okay, let's move on. Now, electrophoresis, okay, we use electrophoresis in biochemical analysis. What is it for? Okay, we use it to separate and identify and purify proteins. Okay, it is based on separating ions placed in an electric field. So it's like something like a chromatography, like a paper chromatography, if you want to put it in that way. But we are going to separate it. The ions are going to be separated using electric field. Okay, and it is used for protein. Okay, if a sample is placed between two electrodes, okay, positive charged ions will move towards the negative charged electrode and vice versa. Okay, so this is electrophoresis. So like for example, okay, this is going to be electropherogram. Okay, how if you can see bands over here, okay, it means these bands appears because of the ions, the charge of the ions are being pulled to different by the electric field. So a sample is how it is done. Yeah, a sample is placed on absorbent paper. What is absorbent paper? Is actually like a gel supported on a solid base. Okay, we place it in a on top of glass plate. It's like a plate. Okay, and there is a gel. Okay, there's a gel. So we have to add a buffer solution. What is the buffer solution's function? It's going to carry the ion. Okay, it's going to be carry the ions along. So the rate of movement depends on the size and the charge. If you have larger ions, they move slowly. If higher charge ions, they move quickly, because more charged ion, they are going to be attracted to the electric field better. Okay, so a series of lines of bands appear once a chemical is applied. So this one you still need to protein, they don't have color, so we still need to see them. If you want to see them, you need to stain them. Okay, so we need to stain. So to stain them, we use chemicals. Okay, and after that, we even though you stain them, it's not so clear. So what we need to do to see the bands, you need to use UV light. Okay, so you can see the bands. So these are the bands. Okay, I think these bands, if you look at here, even I think you can say that this sample is the same as this sample. Can you see? So this is going to actually help us, like something to do like if you want to identify, okay, let's say using protein sample. Okay, I want to actually identify using electrophoresis whether this is what I'm looking for. Like for example, I have, okay, the protein, okay, the band electropherogram for pork DNA, okay, or let's say protein of pork. Yeah, so if I have that, okay, if I want to find whether in that particular food I have pork, okay, so I do electrophoresis, then I can actually find out if the bands are going to be the same, then that food contains pork. Okay, so this one is actually simple test, can be used. I think in Indonesia, I think you know about this halal certification. Okay, so the halal certification, they actually use all this to find out whether do you have certain proteins that are not allowed according to the religious belief of Muslims. Okay, so this is actually some of the uses. Yeah, so you can read more. Okay, but in chemistry, so what we do is electrophoresis. We know that the amino acids, okay, they have charges. Okay, so we have learned about these zwitterions. Okay, so here, like for example, if you have just like this, okay, this is glycine. But if you have the R group attached with another something that has NH2, this is going to be basic. Okay, this one we have learned earlier. If let's say the R group is attached to something that has COOH, then it's going to be acidic. So we can see the charge, okay, the charge of the amino acids depends on the pH of the solution also. So if you look at here, okay, like generally zwitterions, positive and negative, they cancel with each other. So the B, okay, they are going to stay in the middle. They are kind of like something like neutral. Okay, but overall charge, you see this positive and negative cancel, but there's going to be lysine will have positive charge. So positive charge will be attracted to negative part. So you see the A plus, okay, they are attracted towards the negative. The most probably A is going to be lysine. And if you look at C, okay, they are attracted to positive. Why? They must be negative charge. How to identify their negative? Positive and negative, they cancel. This is negative. So it depends, okay? It depends on the pH of the solution, okay? So this is the principle, yeah? The principle of gel electrophoresis. So it's quite simple. Now, electrophoresis, okay, when I think some of the things, when separating a mixture of proteins, they are treated with chemicals to make them all negatively charged, because I don't want, if I have positive plate and negative plate, okay, let's say this is electric field, I don't want some of them go here, some of them go here. I want everything to move like one direction, like my paper chromatography. Okay, so how do I do that? I will treat them, okay, with chemical to make all of them negatively charged. If they are negatively charged, they are going to be attracted to the positive terminal. They are going to move towards positive. So first, we need to add with chemical or a buffer solution. Just now, remember there is a buffer solution. So they are going to actually, those are the chemicals to make them negatively charged. Justin mentioned about, do the series of bands appear differently when the pH is changed? When the pH is changed, series depends on if you're comparing, like for example, different pH, are we going to have different pattern of the band? Yes, the answer is yes. Okay, are we going to have different patterns? So that's why for that particular not only electrophoresis only, Justin, even for paper chromatography, if you are using different solution, like for example in paper chromatography, if let's say you dip it into water and you dip it into alcohol, okay, the pattern is going to be different because the way that they move is going to be different. So it's the same concept as well. Different pH, they are going to have different pattern. Yeah. So I might be wrong. Okay, but again, if you want to do more reading on electrophoresis, please go ahead. You can do more reading. But what is important over here is you need to know that the charge, okay, the charge depends on the pH. Okay, it means that where do they move? Okay, but if you are using certain chemicals to make them into same charge, okay, if you make them as say like for example move to one direction, okay, so that is going to actually be the pattern might be the same. Okay, I'm not sure also. Okay, so it depends on the principle of electrophoresis. Yeah. Now all of the proteins will migrate with the same direction. Okay, because if you are using the chemical, they put it into all negatively charged towards positive electrode, but the larger protein moves slowly. Okay, so bigger protein moves slowly. So a dye can be added, okay, because protein are colorless. So you need to actually add dye so that you can see. And then again, don't forget they use UV light to see the bands. And then you can these are the some of the questions. Okay, we can try the questions with the answers and everything is there. Okay, and that's it. Actually, this is the part, the last part is going to be electrophoresis is like the part that we learn, you know, it's like if it comes out, then they can actually ask only maximum 2 marks or 3 marks question. So what do we need to know when it comes to what do we need to know when it comes to electrophoresis? We need to know what electrophoresis do. Okay, they are used to identify protein. Okay, and how do they work? How do you identify, okay, the band? Okay, so how to apply, how to compare, okay, all this will be there. Okay, so it depends. Okay, but less questions on this electrophoresis. Last time this part used to be a bigger portion in your syllabus, but now they have reduced it. Okay, so not too much on this position, not too much on this part. Okay, but you need to know, you can see, like for example, they say electrophoresis is carried at a buffer of pH 10. Okay, different pH, different, yeah. So at pH 10, draw the ions present in this alkaline condition. So glycine, valine, and phenylalanine, they you can refer from the textbook. So when you have this is from the textbook, yeah. So this is glycine, valine, and phenylalanine. So if you are going to use at pH 10, okay, so we know that this is going to be NH plus. This is going to be C. Yeah. So this one, okay, they have written over here. So here, if it is going to be at pH 10, okay, pH 10, so it means that the H plus, okay, the H plus will go and react with the with the alkaline condition. Let's say if you are using sodium hydroxide, so the H plus from the carboxylic acid will go, and you will get this ion. And the same thing here for valine, okay, the H plus will go and you will get this ion. The H plus from here will go, you will get this ion. These are the ions, okay. So these are the chemicals to make them into the same charge, a negative charge. And then draw a sketch of electropherogram that you will expect, labeling the glycine, valine, and phenylalanine. Okay, explain. So important is, if let's say you start over here, if this is negative, this is positive. Okay, so we know that all of them are negatively charged. they are going to be attracted towards negative, so they will move over here. But which one is going to be moved further, okay, which one is going to be not so separated, it depends on the size and the charge, and all of them have the same charge over here. So it means it's has to do with the size. We know that this is very big, C6, okay, C6, so it's going to be very big. So this one will come over here. This is the smallest, so they will come over here. So when they explain, they are separated according to the size, okay. So the smallest is going to be moving further or closer to the positive terminal, and then the phenyl aniline is going to actually move at the shortest distance, okay. Any question, Shane?
No.
Okay, so I think this is done. Okay, so I think if you look at the part about this electrophoresis, it's just similar to trying to separate. Okay, and then when you want to actually answer the questions, okay, you in this case they are asking you to refer to the textbook. Okay, like in the actual situation, they'll ask you to refer to the data booklet. Okay, so using the data booklet, then we will try to answer those questions. Okay, so if you are using different solutions, okay, it's going to be different, yeah, different bands or different shape, okay, different separation, okay, but again the concept is still the same. If you have bigger, okay, so of course they are going to be further, they move little bit only, okay. If you have smaller, okay, smaller, like for example glycine, then they will be separated more, okay, so something like that. So in this case, let's say if we change this question into pH equals to 5, for example, what is going to happen is going to be on this one, okay, you will have NH3 plus, okay, you're going to get NH3 plus. So all of them are positive charged, okay. So what happens is going to be they are more towards here. So all the bands, okay, will be coming over here then, okay, closer to negative. So this one you need to learn, okay, how to apply, okay. These are the summary, okay. I think the summary you can read. We have done everything, okay. Maybe for today we started from, maybe we start from amino acid, yeah. So there are 20 naturally occurring amino acids, okay. This one is your bio, yeah. So 20 amino acids, okay, they have their own name in bio, okay. So the amino group, okay, that interacts with the acid group to they actually form zwitterion, okay. Amino acid, they can behave as buffers, so they can react with both acid and base to form salts. Okay, two amino acid, they react together, okay, it's a condensation reaction to form a peptide, okay, and then you can actually get a polypeptide, okay. Polypeptide is protein, yeah. So amides, how do we prepare amides? There are two ways. One, you react acyl chloride with ammonia, or you can react with amine. If you want just amides alone, unsubstituted amides, you react with ammonia. If you want substituted ammonia, how do I know? Substituted amide, how do I know it's a substituted amide? The moment you see N something, that is going to be substituted amide. If you have substituted amide, then you must use amides, not ammonia. Yeah. So amides, what are the reactions? They can be hydrolyzed by both alkali or acid. And if you both of them supposed to give you carboxylic acid and amine, but if you are using acid, the amine will react to give you NH3 plus. Okay. If you are using like base, okay, what happened? The carboxylic acid is going to give you RC double bond O, okay, then Na plus, something like that. Okay, so this is important. And the last part that we have learned, electrophoresis uses electric field to separate the compounds in the mixture. It is used to analyze sequence of amino acids in protein. Okay, so how do we analyze? Okay, we use electrophoresis. How electrophoresis at least work, you need to know. Okay, so we are going to use a chemical, change them into the same charge ion. and then we will actually use electric field to separate them, and they are going to be separated according to the size and the charge. Okay, so the bigger size will move less, more uh, smaller but amino acid will move more. Okay, so that will create a band, and this band you still need to use dye, a chemical, to see, and this dye we need to also use UV light to see. So these are the important points that we need to learn. Okay, it's already 12:31. All this is done. I even actually took some questions from end of the chapter, and then the answers are there. So this one I want you guys to actually do. We don't have time actually. We are kind of because of the revision that we did in week number 1, we are slightly behind the schedule. So this topic, okay, I still want you guys to do your own revision. Okay, maybe before we do questions, I think you do your own revision. Okay, this one is all organic part is done. I give you some time to also study all the organic parts. Okay, finish that, and then we will start with our revision on the paper 4. Okay, then all the organic parts are going to be there, so we can see. Okay, by now, even if you have any paper 4, you can start doing the questions, because you should be able to complete everything by now. Only things that you cannot complete, I think, related to chemical analysis. Okay, that one we will learn. So now what we will do, the next I will try to stick to the planning. Okay, so this week we supposed to enter a new chapter, but again this is already Wednesday. Yeah, so we are kind of behind by 3 days. Okay, so let me actually catch up to the planning first. Okay, then we will actually look for revision if we have time. Okay, so let's actually, because the revision is planned, if I'm not mistaken, starting from week number 6 or week number 5. So I want to actually catch up to that. Yeah, so let's actually stick to the plan. So the next part that we are going to do is going to be the next chapter. Okay, this one you read on your own. Okay, the next chapter is going to be polymerization. So we have 2 more chapters to go. I think polymerization and analytical chemistry. If you look at your textbook, there is one part they mention about chemical synthesis, organic synthesis, chapter 30. This one I mentioned to you. Chapter 30, I will not do it as a formal thing in class, because we have been doing it through questions and so on. So that part you read as well. Okay, so chapter 30, you do not need to wait for me to do, or for you to finish the analytical chemistry. You can just read through chapter 30 now. Okay, because everything that you have learned under organic chemistry is summarized in chapter 30. So that is actually not something new. There's no additional stuff over there. They have combined, okay, all the reactions. So please read that. We will just straight away, it means now we have only 2 more chapters to go. Okay, polymerization and as well as chemical analysis. Polymerization is not that difficult. Okay, we can do it very fast. But chemical analysis, most students will have problem. Okay, so I think we need to spend more time also on that. So let's actually focus on the chemical analysis. Any questions, Nico, Trisha, Aneta? Any question?
No, sir.
Okay, so if you have anything, if you're not sure, let me know. Okay, related to electrophoresis, if you want to read more, please read. But for me, textbook is good enough, because when I see the questions, is they don't ask a lot on electrophoresis. It's not that popular. Yeah, so that's why I told you, if there is a question, only 3 marks. Okay, maximum 4 marks. Okay, so let's try not to focus on that. Okay, because let's focus on the reactions. Even if you look at the reaction, the organic nitrogen compound, that reaction doesn't have a lot of reaction. You know, they actually mention about how to form amine, how to form amide, what are the hydrolysis reaction. Those are the reactions that are very, very important. And these reactions that we have learned, they will always ask in a combination of organic chemistry questions. So rarely there is a question, just one question from this chapter. No, it is always going to be a combination. Okay, like yeah, like a sub question. Okay, like 3 marks or something like that. So we are looking into that. Okay, please prepare on that. Charlton, any question?
No.
Jason, any question?
No.
Okay, good. So this is done. Okay. If I get the time, I will try to make some videos, but please do your own revision related to organic chemistry. So it means now organic chemistry is done. We will focus on the polymerization and chemical analysis. Polymerization, I never created any video before in a YouTube channel, but you can look at chemical analysis videos in the YouTube channel. So by now we do have all the videos from the entire syllabus, okay, in YouTube. So if you want to revise, you can just type it over there and it should appear. Yeah. I have even done some paper for discussion videos with your seniors, and it's also there. So if you want to revise, okay, you can actually do that as well. Okay, there's a lot of resources over there. Actually, most of the JC2 stuff, okay, the students, I think some of our students are don't want to go and Google, don't want to type and so on. Okay, because too many things to study and then not enough time. I do understand, but if you have the time, okay, please go to that channel and try to actually revise from there as well. Yeah. So it is going to be useful as well. It's all that there. Yeah, especially the chemical analysis. Okay, because we have done some revision questions. I think this video was recorded during the time that we had I did some extra class during the holidays with your seniors last time, so it was recorded. So when they are preparing for their A2 exam. Yeah. So anyway, that's it for today. Okay, see you guys. See you tomorrow. Bye.